Hello my fellow CAD lovers, and welcome to the fifth part of this tutorial on modeling a spiral casing using Autodesk Inventor. The goal of this part is to get to the final geometry of this sheet metal component 0102. As I mentioned in part 2, the location of the work plane we use in the master part to create the first curve for this component was only temporary, and to get to the final location we need beforehand to create the surrounding geometry. So we will start by creating this deflector, then these two rings. So the deflector geometry is already in place in the master part. So inside this sketch WP location, so I'm going to show the sketch. Since we do not want to use this entire sketch, when we will invoke the make part tool, we are going to create an additional sketch where there will only be the deflector geometry. We will start a new sketch and we will use the XY plane. And using the project geometry tool, we will include only the geometry for the deflector. So the lines and the arc. Then we finish the sketch and we will hide this sketch again. And we are going to rename this sketch deflector. And this will be day 1. So now we will save the sketch and invoke the make part tool. For sketches, we are going to browse to this deflector 1 sketch and include it. Then we will select the deflector length as model parameter. This is basically all we are going to need. Next, the part name will be D1 as deflector 1, and for the template we are not going to use the sheet metal template this time, but we are going to use the standard millimeter.ipt template. The file location will stay the same. We will keep this place part in target assembly, and for the assembly name, you can see that the name of the assembly is changed, and this is because I close my Inventor session in between two recording sessions. So what you need to do in this case is to just type in the name of your assembly. So I am just going to copy this because this is the name I use, and making sure it's the same. Okay, spiral casing with some space. And now we can just click on OK, and as you can see, the new part is inserted in the assembly. So as we did for the sheet metal component, we will double click and enter the edit mode for the deflector. But for some reason I directly enter the sheet metal environment, and what we want to create is a part. So what we are going to do is to convert to a standard part. So move to this 3D model tab and you will have this convert to standard part. So we convert it to standard part. You can go the other way around using this button, convert to sheet metal. Okay, so to create the deflector, we are just going to use this profile, and we are going to invoke the extrude tool in the 3D model tab. So we select extrude, and as you can see, the profile is pre-selected for us. So now we need to input the distance. So we want it to be symmetrical, so we are going to choose this option for the extend. And for the distance, we are going to look for the parameter deflector length we added from the master part. So list parameter and deflector length. And as you can see, we have the deflector created. Okay, so now we will return to the assembly And as you can see, this component size is not the correct one since it is not touching this face of the deflector. We are going to have to make this sheet metal component a lot bigger so that it also touch this face of the deflector, and we are going to have to trim this one also. Okay, next we are going to build the two rings. If we switch back to the print, they are depicted in this view. So the first ring will be this one, and as you can see, it is not a really complicated geometry, so just a cylinder with an opening at the center. The outer diameter is 815 and the inner diameter 690, and the thickness will be 35. Okay, so we are going to build it from the master part. We already have the sketch for the outer diameter, which is this ring opening sketch. So we are going to invoke the make part tool again, and we are going to select this ring opening, and we are going to select the deflector length. So the name for the first ring will be R1 as ring 1 and standard millimeter as the template. I will intake this to see what difference it makes, so let's do OK. Then we will double click to edit this. Now as you can see, we are directly in the standard part modeling environment. So that was the trick. Okay, to create the first ring, we want to start from this face of the deflector, and we know that this face is at the deflector length divided by 2, so we cannot use this sketch directly. So we are going to project it onto a parallel plane, which will be at a distance of the deflector length divided by 2. So moving to this work plane features, in the 3D model tab, we are going to select offset from plane, and in this origin we are going to select the XY plane, and for the distance we are going to look for the deflector length, and we are going to make sure that it is divided by 2, then enter. Now before we create a new sketch onto this plane, we have to do some house cleaning. As you can see, the cycle for the ring opening is showing off in all these components, so we have to make sure that we will select the one from this feature coming from the master part. Okay, so we are going to have to go back to this component and expand the folded model, get to the derived part and hide all these sketches. So I should have done that before, but never too late. Okay, so let's hide them all. now there should be only one of this cycle visible, so I will toggle off the visibility. So okay, we are good to go. So again, visibility, and now we are going to start a new sketch on this plane, and using the project tool we are going to select this sketch, and for the inner diameter we are going to add an additional cycle with a diameter of 690, and we will exit the sketch and right away invoke the extrude command to create the geometry, and we are going to select the region between the two cycles. So we will click inside. For the thickness we will use 35 millimeters if I recall correctly, so 35 millimeters. It will be on this side, so now we can just OK to finish. Okay, now for the second ring, so we make sure we have this hidden, and also okay, we did this, and we will toggle off the visibility of this one before moving to the second ring. Okay, now again back to the master part, make part, we use this same sketch, and again the deflector length as a parameter. The name will be R2. For the template we will use the standard millimeter.ipt. We make sure that we unlink sheet metal stars, then OK. And now we have this second ring in place, and right away we jump in and we create the offset plane as we did for the first one. So it will be from the XY plane. This time we want also the distance to be deflector length divided by 2, and we are going to add a minus in front of the parameter so that the plane is created in the opposite direction, then enter to accept. Next, a sketch on our new plane. We project the cycle so that we have the outer diameter. Now we are going to create a second cycle to represent the inner diameter, which will be also at 690, and we are going to add an additional extrude letter to make the final geometry. The total thickness should be 50 millimeters. So let's get to it. Second cycle as we did for the previous one at 690, then we finish and right away extrude. We use once again the region between the two cycles. We want the thickness to be 50 millimeters, and we want it to be in the opposite direction like so, then OK. Now we will create an additional sketch on this face and right away a cycle, and we want the diameter to be 710. Looks OK, and we finish, and then we will extrude. For the first extrude we use this option, which is to add material. So this second option will subtract material, and we want the final thickness to be 15 millimeters. So we will have 50 minus 15, which will be 35. So 35 millimeters, and there we go. So now we will hide this first, so visibility off. For the work plane also visibility, where are you? Visibility here. And we need to create mounting holes, and they are depicted here. So there are M27 threaded holes on a diameter of 765. So we will have 20 of these holes. And as for the depth, I don't think we have a dimensions on the print, so we are going to have to come up with something. Position the first hole, we will have an angle of 360 divided by 20, which is 18 degrees, and we will divide that by 2, so we have 9 degrees. Okay, that's all right, so let's do it. So we'll create another sketch, and we're going to align the view. We are going to create a cycle first, and we want the diameter to be 765. Then we will add a line, so from this to, let's see, here, and we want to add a dimension between the x-axis we do not have right now, so we are going to project, we are going to show, or maybe let's show the x-axis, and then we will project it into the sketch. And now we can add this angle dimension, which is 9 degrees, and from there we are going to create the hole at this endpoint. So finish the sketch, and then we invoke the hole tool. The placement option should be from sketch, and then we will have a drill hole. The drill point should be at an angle of 818 degrees. We will change this option to tape hole, and we make sure that the thread profile is an isometric profile. And now we are going to select a size of 27 millimeters, and for the pitch, let's say 27 by 2. Okay, now for the drill depth and the thread length, we will have for the thread depth, let's say something like 25 millimeters, and the drill depth should be 35 millimeters. And now we have to select the center of the hole, so we will just select this endpoint, and as you can see in the preview, we have a hole created. So now we just have to accept the input, and we have our first hole created. Now we will use the circular pattern tool, which is in this pattern panel in the 3D model tab. So circular pattern tool. For the feature, we will select the hole, and we need an axis of rotation, so we will select the Z axis. And now for the number of instances, we need 20, and the total angle should be 360. And as you can see on the preview, the holes are created, and we are basically done for this component. So we will toggle off the visibility. We could add some chamfer to break the sharp edge here and there, but not the focus of this tutorial, so we are just going to return to the assembly. Now that we have the surrounding components in place, we can go ahead and make the necessary change to properly size this component. And the way to do that will be to play with the section sketches at this location, or more precisely how the cross section sketch at this location is positioned. So in part 2 we did some rough positioning like this, and now what we want to do is to increase the radius and the length. To do so, we are going to have to move this plane as shown here. So we are going to make this line a little bit longer, and basically we are going to mimic the way the other planes our position. So we will have a line with a length, let's say 240. This is what I found working the best, and at 20-degree angle. Now let's go back to the master part, and we want to show this sketch, and we are going to also edit it, and we are going to remove the constraint we added to this line. So remember, this is the line that defines the location of the work plane we are interested in. So the way to do that is to right click on the line, and in the context menu you have this delete coincident constraint. So it will remove the coincident constraint closer to the location where you right click on. So now you can see we can move this end of the line freely. So we will do the same for this end. So we right click and remove coincident constraint, and now the line is free to move. So next we are going to add a coincident constraint from this endpoint. So we will not change this line location, but we will constrain this endpoint to this one, and we will grab this endpoint and move it to somewhere like this, and then add a new line from the center to this endpoint. Now we will add dimensions, so align dimension for this one, and we will input 240. Next, an angle dimension between these two lines, so this one will be at 20-degree. So as I tried to explain before, these values are the result of several iterations. I didn't stumble upon them by magic. I did a couple of tries and error, and then I found that this was the best working dimension. Okay, so to finally define the position, we will add a constraint between this and that. Okay, so now the center point of the cross-section curve will be this endpoint, and this endpoint will define the radius, so that we will have something bigger. And since the two work planes location are now far away one from the other, we will have something bigger. So this should do the trick. Okay, so now as you can see, this whole section sketch is no longer properly located, so we are going to have to fix that. So we select it and edit sketch, and maybe we should hide this for now. And as you can see, maybe this is what is not working. So first we will remove this constraint, then we will delete this line, and now we can move the arc freely. We will show this again, visibility, and project this onto the sketch, hide this again, and now coincident constraints to from this to this center point to this endpoint, and we'll bring the symmetry back between this line, and using this as the symmetry line. Then finish the sketch, and now we can go back to the assembly, and we will update the assembly. And as you can see, the part is updated, and we can already see how the change is performed. Now the component is properly seated on the rings, and what is left to do is to trim it so that it is perfectly fitted to the deflector. Okay, so we are going to select the component and edit it, and we will need to add the deflector profile and use it to perform the trim. So we are going to edit this, the derive path feature, to add the deflector profile. So this one, and then okay. And what we will do with that is to create a new sketch onto the XY plane, and we will project only this line. Okay, so now we will hide this deflector profile. So right click visibility, and now we will just create a rectangle by 3 points to define the area that will be removed, something like this, roughly like this. Then we will add a collinear constraint between this line and this one. We will add some dimension, it doesn't matter, and we'll make an horizontal constraint between this endpoint and the origin, and to finish we just throw in a dimension like this. And now the sketch is fully defined. We can close it and perform the cut. The profile is automatically selected, and we will use this 650 as the extent. We want it to be symmetrical, and okay. So let's close and return, and as you can see, we have the component properly positioned. So feel free to play with how the work plane is located. So maybe I will show you how I did some iterations. So for instance, what I tried was to am I in the correct sketch now? So this one. So what I'm trying to do is to increase or decrease this value to see how the geometry was affected. So for instance, if you use 200, you will see the radius will increase. Let's go back to the assembly and update. You see the radius will increase, and this portion will extend over the ring 1, which is not good. So this is not a good idea. So we go back and change this value to, let's say, bring this back to 240, and if we, let's say, decrease this angle to 10 degrees, finish the sketch and back to the assembly update, you can see that there is not a very distinct change, but looking inside you can see that there is a small gap here which is not that great. So I found that the 240 and the 20 degrees were good compromise, so I am going to stick with that, and you are free to go with what your gut tell you. So we are going to do with that. Okay, so it's also the case with 20 degrees. I didn't notice that before, but you can play with the value to try to fix that. Now we have to fix the interference between the deflector and this part, and a good way to check if there is an interference in your assembly is to use this inspect tab and the analyze interference tool. So in the interference analysis tool you have two selection sets. So the first set will be, in our case, this component, and the second set will be this one. And now you can see when we click on OK, the interference volume is displayed in red. So we are going to have to trim this component to avoid the interference. So okay, and we are going to do the same as with this component. So we'll edit and then edit the derived part feature, then add to the selection the deflector, and as we did before, we are going to create a new sketch into which this line will be included. So this will project this line. Okay, finally. Now let's select this and right click visibility. Now, as we did before, we will add a rectangle by 3 points. So 1, 2 and 3. We'll make a horizontal constraint, then collinear constraint between this line and this one, and then we will throw in some dimension, so this and that, just to fully constrain the sketch. Now we can finish the sketch and perform a cut. We will use the same options as we did before, so the same distance, the symmetric extent, and OK. So this is the part where I can guarantee that this result is realistic, but I won't be surprised it is, because my guess is this cut will be performed after the part is formed, and maybe this portion will be left to be grind off before welding the components together. I don't know, maybe yes, maybe no, but this is my guess. Now that we solve this interference, we will return to the assembly, and this will conclude the 5th part of this tutorial on modeling a spiral casing in Autodesk Inventor. In the next part, we are going to leave the main case and we are going to move to the outlet side. We are going to create these two sheet metal components, these two parts, and then the shim, and finally the flange. So hope to see you then, and thanks for watching.